Okay, so we're talking about piecewise today. You should have talked about it in Math 2 or Math 3 or maybe both. But if not, then here we go. So the first thing we're going to do is evaluate a piecewise function. And so a piecewise function is pieces of functions. That's why it's called piecewise function. Okay. So the first thing we're doing is evaluating. So if we look at this, we got f and we've got g. And f has two different equations. G has 3. So if we look at number 1, we want to find f of negative 3. So I'm just looking at f, and I want negative 3. So you have to decide which equation that you want to plug into based off of the inequalities. So if I look at negative 3, is negative 3 less than 5, or is negative 3 greater than 5?
Less than 5.
Less than 5. So then we're plugging it into the top function. Everybody okay with why we picked the top function, not the bottom one? Right now it don't matter. We'll use different colors for the graphs. And then we just simplify it. So if I simplify that, what do I get? Good, negative 5. And that's it.
Pretty simple.
Yeah. Questions? Shh. Alright, so number 2. So number 2, we want f of 10. So is 10 less than 5 or greater than or equal to 5?
Greater and equal to 5.
Good. So then we plug it in right here, which is just negative x. So negative 10 is just negative 10. So that's it. Okay. How about 3, f of 5? Which one would I plug in if it's just 5?
The bottom one.
Why?
Because it's equal.
Good. So it has that or equal to, so we're plugging it into that negative. So again, that's just negative 5. Any questions on f function? Let's look at g. So g, we have 3 options here. So we're looking at negative 4. So is negative 4 less than or equal to negative 2, between negative 2 and 0, or greater than 0? Negative 4?
Oh, negative 4.
Less than negative 2. So we plug it into the first one. So negative 4 plus 3. Which is what? Good. Yep. How about 5? If it's negative 2, which one do I plug it into? The first one as well, because again, it's got that or equal to. So negative 2 plus 3 is what? 1. Good. So how about number 6? We want g of 0. Which one can I plug it into? So would it be the second one or the third one?
Because it's not equal to 0.
It's not equal to 0. Are either one of them equal to 0?
You got a point.
So then you just say no solution. Or you can say undefined or something like that. So if it gives you a number that's not in those inequalities, no solution, undefined, something like that. Any questions on evaluating? Okay, so now we're going to graph them, and this is where you'll use your 2 colors. So I'm going to say my first one is blue. And so if I look at this x minus 2 and x plus 3, what kind of graphs are those? What kind of shape are those going to be?
Straight line.
A straight line. So they're just linear, so there's going to be straight lines. So what we have to decide is where they start and which direction that they go. So the easiest way to do that is to make a little table. Okay. So if it is a linear graph, so you just have x as your variable, or if it's just a constant, you need 2 points. Okay, so you're needing 2 x values. It gives you one of them. So the first x value that it gives me is negative 1. Okay. But then if I look at this, it just says x is less than negative 1. So then we just have to come up with a number that's less than negative 1. So what's less than negative 1? Negative 2. Okay. So it gives you the first one. Sometimes it gives you both. We'll look at that. But it gives you the first one. You find the second one. Okay. So then you do what we did up here and you just plug them in. So if I plug in negative 1 minus 2, no, because we're looking at less than negative 1. So good, so negative 3. And then we're looking at negative 2, so negative 2 minus 2 is negative 4. Okay, so I have 2 points, negative 1, negative 3, and negative 2, negative 4. Questions? Okay. So the first one, negative 1, negative 3, that's what the equation gave me. So if x is less than negative 1, is that an open circle or closed circle when you're graphing it? Open. So if it's just less than or just greater than, it's an open circle. So I have an open circle at negative 1, negative 3. So negative 1, 1, 2, 3. But then the other point we picked, we didn't have to pick negative 2. We could have picked negative 3. We could have picked negative 100 or whatever. So that point just tells us the direction that the graph goes. So we go to negative 2, negative 4, which is here. And that's just telling me that my graph is going this way. So it's not stopping at that point. Because again, we picked that point. We just picked it to see which way the graph goes. Yeah.
So like you say that, like that dot describes how like which way the graph goes.
Yes.
So like if you do like 100, like it'd be more straight up. Like how would they all be the same?
Well, we would have to do negative 100 because it would be down here. So then it would be somewhere like over here. So it would still be going down. The other way that you can do it is look at your slope. So like on this one, our slope is 1. So if I wanted less than that, I would have to go down 1 over 1. So you can also do it by slope. You don't have to do it with the table. Any other questions? Alright, let's look at our next one with our other color. And so we want to do the same thing for this, make a table. So if I look at this one, I want x's that are greater than or equal to negative 1. So negative 1 is still my number I'm looking at. But now I want greater than that. So what's greater than that? 0. Yeah. And so again, you can pick anything greater than that. Of course, you want it to fit on your graph, but anything greater than negative 1. Okay. And then again, we're just plugging it in. So negative 1 plus 3 gives us 2. And 0 plus 3 gives us 3. Okay. So this one was greater than or equal to negative 1. So is that open or closed circle? Closed. So we have a closed circle at negative 1, 2. So negative 1, 2, closed circle. And then again, our next point just tells us which way our graph is going. So we're not stopping at 0, 3. It just tells us our direction. So I go to 0, 3, which is here. So then I know my graph is going up this way. Questions? Alright, let's look at the next one. Okay. So on this one, we have x minus 1 if x is less than or equal to 3. So again, we want to do a table. And in this one, it gives me 3. But I want all the x's that are less than 3. So what's less than 3? 2. And then again, we just plug it in. So 3 minus 1 gives us 2. And 2 minus 1 gives us 1. So do I have an open or a closed circle at 3, 2? Closed. So we go 1, 2, 3, 1, 2, closed circle. And then our next point, 2, 1, again, it just tells us which way we're going. So 2, 1 is here. So we're going this way. Questions? Alright, so this next one is a little bit different. So if I look at this, it's just negative 1. So we can still make a table. Again, it gives me that x is greater than 3, so we have to use 3. What else can we use? 4, yeah. So anything that's greater than 3. But if I look at this, do I have an x to plug into? No. So no matter what x you pick, your y is negative 1. Okay, and this is just a constant, a horizontal graph. So both of my y's are negative 1. Okay. So we don't have an x to plug into. It's just a horizontal line. So open or closed at 3, negative 1? Open. So 3, negative 1 is open. Mm-hmm.
Well, I thought it was greater than 3, because it doesn't say greater than or equal to.
Yes. So you don't want to skip and go to 4 because you still have those decimals between 3 and 4. So like your x might be 3.000001. So then you include 3, but that's why it's open. So it's saying it's starting at 3, but it's everything after that. So it starts at 3, but it doesn't include the 3. Does that make sense? Oh, yes. Yeah. Brittany. Lindsay. So then 4, negative 1 is there, and again it's just a horizontal line. Questions? We already did that. I also got 3. Yes. Yeah, she's right there. Okay. So this one has 3 parts, so let's start with this first one. So again, this one is just -3, so we're not going to have an x, so it's just going to be that horizontal line. But we still need to see where it starts. So we'll make our table. And what x value does it give? -1. So we start there. And then we want less than or equal to -1, so what else can we use? Yeah. But again, we don't have any, we don't have an x, it's just that constant, so no matter what, our y's are -3. So open or close circle at -1, -3. Good, close. So -1, 1, 2, -3. And that tells us where it starts. That -2, -3 tells us which way it goes. So it's just a constant, straight, horizontal line at -3. Questions? Alright, so the second one is different. Why? Good, so it gives us 2 points. It gives us -1 and it gives us 2. What else is different about it? Good, it's an x squared, so it's a quadratic. So when you have an x squared, you need more than 2 points, okay? You have to have at least 3. So let's look at x and y. So it gave me -1 and it gave me 2. Now, if it was a linear, we could just plot those and then we would be done. But since it's a quadratic, it's not going to just be a straight line. It's going to be a parabola. So we also need a number that's between -1 and 2.
1.5.
How about let's say 0? So then we plug them into x squared. So we do -1 squared. And -1 squared is 1. Then we do 2 squared. And 2 squared is what? 4. And then 0 squared is 0. So open or close that -1, 1. Open. So -1, 1. How about 2, 4? Open or close there? Open as well. Good. So 2, 1, 2, 3, 4. And then our point 0, 0 is here. So remember, when you graph a parabola, you want that vertex. So in this graph, that's that point 0, 0. So it goes down to 0, 0. It goes through 1, 1 again, and then up to that 2, 4. So I knew that the vertex was going to be at 0, 0, but maybe you didn't know that. So what you can do is go in your calculator and graph it. So in this one, it's just x squared. And so there it is. Well, we don't want the whole thing. We just want from -1 to 2. So if we go to our table and we look at -1, well, there's our point, -1, 1. And then you got 0, 0, 1, 1, and then there's our other point, 2, 4. So you can see from the table that that 0, 0 is that vertex. Okay. So if it's a quadratic, you just want to make sure you can type it in y equals and check your points on the table. Okay, but this one has one more piece. So let's look at this last one. And so what x value does it give me? 2. And if I want x's that are greater than or equal to 2, what's our next one? 3. So this one we do have an x to plug into, so we just plug it in. So -2 plus 6 gives us 4. Oh, sorry, not -2. What am I doing? Oh, yeah, it is -2. This is negative. And then -3 plus 6. Which gives us 3. So my first point is at 2, 4. Open or closed? Closed. So I go to 2, 1, 2, 3, 4. I already have a point there. So what happens is this closed point at 2, 4 just fills in that open circle at 2, 4. Okay. So the only thing you don't want is 2 open circles, but an open and a closed is fine. So then our next point, 3, 3, just tells us our direction. So 3, 3 is here. So I'm going this way. Questions? Okay, so this last one, number 4, it gives us the graph, and now we want to find all of these, we want to find the y value at these given x values. So it's the same thing that we did for those first 6, but instead of having the equation, now we have the graph. So if I'm looking at f of 0, that's what we've been plugging in. So we've been plugging in our x values, and what do we get after we plug them in? Y values. Good. So if I'm looking at 0, what's my y value at 0? Would it be 0? Or would it be 1? Which one? So would I use the 0 or would I use the 1? So we want to use the 1 because the 0 is an open circle. So that's what I was saying earlier. That's just telling you that it starts at 0, but it doesn't include that 0. Okay? So you have to have either a closed circle or a solid line is what you're looking for. So then if I go to 3, where x is 3, what's my y value? 1 again. How about if I go to where x is 8? Yeah, again, it's up there at 1. How about -2? 2, yeah. What about regular old 2? Well, I have an open circle at 2. Well, if I'm at 2, there's nothing else here. So then again, it's just no solution. Or undefined. Questions? Okay, let's try some.